Iya.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning.
Good morning.
Here I will present about project-based learning or PBL to improve psychomotoric skills, a classroom action research. Kin, the aim of the journal article. First, student can improve the student's concept understanding and psychomotor skill through teaching props production. And then student can expand the knowledge about the use of props in an effort to visualize the abstract topic and also to improve psychomotor skills. And student can increase their concept understanding in the topic. And then student can see, feel, express the thought about the living object they learn. Student can observe the abstract concept inherent and durable in the student. And the last is student can broaden their knowledge about the application of used material as the learning tool. It also can improve student creativity and activity. Okay, next. Kin. Introduction. Practicum in chemistry learning is an important approach to get the better understanding and chemistry application. The laboratory-based learning helps students to find the fact of theories learned in lectures. However, the psychomotor dimension is more important since science learning is not only a collection of knowledge, but also the human enterprises with application of motor skill, such as to stringing and measurement. The skills are also useful for learners in everyday life. The aims of practicum are to increase the concept understanding and student activity. Project-based learning is a form of constructivist and collaborative learning in which the learning process using student-centered learning, which allows students to work together to solve problems and learn from one another along to build their knowledge. Whitley 2012, Gulbahar and Tinmas 2006. And then Yalcin et al. 2009 state that PBL is a comprehensive learning model for students. They can work individually or in groups to investigate a topic. PBL is systematic learning that engages students in knowledge and skills learning through the inquiry development to obtain a product. Widiatmoko and Pamalasari 2012. Again, next. Akinoglu 2008, Doppel 2003, and Yalcin et al. 2009 state that PBL is effective in improving the student performance by a product creation through a trial. In PBL, students can actively involve in learning activity and the teacher can observe their activity during the learning process. Also, during the project, the student psychomotor can be assessed optimally. Students can improve their psychomotor abilities, thinking skills, creativity, and imagination, in line with the increasing of the learning process and its quality. The project which is given to students must stimulate them to create educational products such as the teaching props. The props can be used to provide a basic experience in experimenting and explaining concepts. Glaser and Carson 2005. And also, uh, teachers should help the student to visualize the abstract concept to be tangible and easily understood by the student. Pick Bay and Capcan 2014. Okay, next. A concept that needs a clear visualization is the separation of compounds based on their differences in boiling point using a series of distillation equipment. This separation concept is related to the compound's colligative properties and the separation of essential oil fraction. In high school, there is no distillation equipment. Therefore, students can do the action research by giving them a project to produce a series of distillation equipment using second-hand materials. The result of the study by Widyatmoko and Nurmasita 2013 on project-based learning by teaching props production showed that the student activity increased 25%. In addition to student activity, the research of data et al. 2013 also show an association between PBL and the student skill. It shows 55% improvement of the aspect of props assembling skill. Okay, next. And then research methodology. The classroom action research was conducted in collaboration with teachers at one high school in Semarang. Subjects were students of class 10, as many as 37 students. There are 20, 23 females and 14 males. This research was referred to the spiral model chemist and method, where there are four important stages in classroom action research, namely planning, actions, observations, and reflections, resulting in cycles as shown in figure 1. Okay, next. This is the model of classroom action research by chemists. Okay, next. And then result and discussion. From from the research which was conducted on from pre-cycle to third cycle, we obtained the cognitive learning outcomes and the percentage of classical as shown in Figure 2. From Figure 2, it appears that in the first cycle, cognitive learning outcomes of students not in accordance with indicators of successful achievement at 75%. However, then it was as if in the second cycle. Based on Figure 1, it can be seen that the same learning model as the previous cycle, there is an increase in cognitive learning outcome at the second cycle. Okay, next. This is Figure 3. The increase in the average value of student psychomotor of the cycle 1 until 3. From Figure 2 and Figure 3, it appears that the psychomotor aspect in cycle 1 of each indicator guide response, origination, perception, set, and adaptation has not reached the good category. In the first cycle, the skill to prepare the tools, materials, and completion of the work were low because students had not understood the props of distillation component and its functions. In the aspect of readiness, students tended to pay less attention to the teacher's explanation about preparation of prop distillation and how to formulate and measure of working solution before distillation process. Students also were not accustomed to prepare tools and material lab independently. And based on the result of reflection in cycle 1, the learning cycle 2 was conducted by providing a project assignment for students to make a distillation apparatus which has been planned for the cycle first. And again, next. Figure 4, result of psychomotor skills, achievement of students in cycle 1 and 2. In comparison, the result of cognitive value obtained in the cycle 2 shows that students have increased their score compared with the cycle 1. The improvement of the cognitive value of students from the first cycle to the second cycle was occurred because most of the students began to enthusiastically participated in chemistry learning, and teachers have given sign that learning takes place in an orderly and purposeful. In the second cycle, in general, psychomotor skills of students had increases. In next. Conclusion. Based on the result of action research that had been done, it can be concluded that learning with project work in the form of props is a learning laboratory distillation student-centered is essential and beneficial for students to develop the three domains of learning, namely cognitive, affective, and psychomotor. Working practices play an important role in creating links with everyday life, enabling students to understand the lessons, embody the knowledge learned, and to develop their psychomotor skills and dexterity. Many of the skills that can be gained from these activities include the skills of observation, classification, data recording, create hypotheses using data, and gain the ability in creating, changing, and controlling variables, and conduct the scientific experiment. Okay, next. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.